Right. Good evening, all of you. Good evening, my dear students. Join fast. Good evening, my dear students. Join fast. Yes, we have 30 minutes of session. Join fast. Good evening, my dear students. Good evening, all of you. Good evening, all of you. Good evening, my dear students. Join fast. Good evening, Adarsh. Right. We had just 30 minutes of discussion. Let's start with my introduction. Myself, Venkat Krishna. My qualification is MTech Computer Science from IIT Kharagpur. I cracked GATE examination with All India rank 22. I had more than 15 years of teaching experience, particularly in GATE specialization in 3 different subjects: design and analysis of algorithms, engineering mathematics, and discrete mathematics. Welcome to Unacademy platform. In India, Unacademy is the best online platform for all competitive examinations like GATE, IES, JEE, NEET, SSC, JEE, UPSC, for all competitive examinations. Let's see why it is best. What are the various features? You will have 2 types of subscriptions in Unacademy. One is Plus. Another one is Iconic. In case of Plus, you will have 4 features. One feature is live classes. You had already an experience. Structured schedule will be there. Unlimited practice. You can find in Plus one special feature, unlimited practice. Every day you can find a DPP, daily practicing problems, by which you will get a lot of confidence. That's the best way to clear any competitive examinations, and test series will be available. In case of Iconic, again you have 4 features. One is personal coach. Study planner will be there. You will get guidelines from experts, and you will be having a lot of questions and answers of engineering service examinations. Okay. Now let us see how to take subscription, what will be the duration of subscription, and the fee structure. In case of Plus, let me talk about 1-year subscription. Actually, you will have 1 month, 3 months, 6 months, 1 year, 2 years. My advice to all of you is better to take at least 1-year subscription. Whole syllabus will be covered. So a lot of time will be there for practice, and you are going to meet extraordinary tutors of the country. So for 1 year, in case of Plus, the actual fee is 25,000. Even you have a discount if you use my referral code GVK10. If you use my referral code GVK10, you will get 10% discount. So the final fee structure will be 22,500. In case of Iconic, for 1 year subscription, the actual fee is 45,000. But if you use my referral code GVK10, you will get 10% discount. So the final fee will be 40,500. And these are various payment methods to take subscription either in Plus or Iconic. This is my referral code GVK10. Right. Let's start the session. Good evening, Vasu. Good evening, Hare Krishna. Right. Yesterday we had ended the session with the Laplace transform of derivatives. Am I right? With the Laplace transform of derivatives. So let me recall that and what's the advantage of that. Okay. Suppose we have a function f of t whose Laplace transform is capital F of s. I think these notations are very clear. In that case, the Laplace transform of nth derivative of t Here n is written in parenthesis. It indicates nth order derivative. So therefore, once you know the Laplace transform of small f of t, you can easily get Laplace transform of nth order derivative of f in terms of again capital F. Let's see how it looks like. This is s power n into capital F of s minus s power n minus 1 into small f of 0 minus s power n minus 2 into f dash of 0 minus s power n minus 3 into f double dash of 0, second order derivative at 0, minus, and so on. Finally, here you will get s power n minus n, that is s power 0, into n minus 1th derivative of f at the expression 0. I think this is clear. So it is very easy to remember. And let us discuss two simple cases by replacing n by 1 and n by 2. n place లో 1 రాస్తే మీకు ఫస్ట్ ఆర్డర్ డెరివేటివ్ ఆఫ్ f వస్తుంది. So if you know the Laplace transform of f of t, you can easily get Laplace transform of its first order derivative. You can easily get Laplace transform of its second order derivative like this. Okay, let us see how to remember this formula. Formulas ఎలా గుర్తుపెట్టుకోవాలి? Actually మీకు 9 to 10 సబ్జెక్ట్స్ ఉంటాయి. Mathematics, aptitude, core subjects, అన్నిట్లో మీకు ఫార్ములాస్ ఎలా గుర్తుపెట్టుకోవాలి? You should have some trick. ప్రాక్టీస్ ఈజ్ ఇంపార్టెంట్ అండ్ ట్రిక్ ఈజ్ ఇంపార్టెంట్. వాటి అప్లికేషన్స్ కూడా తెలుసుకుంటే మీకు ప్రిపరేషన్ చాలా వరకు తగ్గిపోతుందండి. మెనీ ఆఫ్ ది స్టూడెంట్స్ విల్ హ్యావ్ లాట్ ఆఫ్ కన్ఫ్యూజన్, హౌ టు రిమెంబర్ మల్టిపుల్ నెంబర్ ఆఫ్ ఫార్ములే, హౌ టు డూ ప్రాక్టీస్, హౌ టు క్లియర్ ద ర్యాంక్. దే విల్ హ్యావ్ మెనీ థింగ్స్ ఇన్ దేర్ మైండ్. జస్ట్ ప్రెషర్ తీసేయండి మైండ్ లో నుంచి. యూ ఫీల్ దట్ ఐ కెన్ డూ ఎనీథింగ్. సో ఫార్ములాస్ గుర్తుపెట్టుకోవడం ఏమీ కాదు. బేసిక్ ఫార్ములాస్ ఏవైతే అంటే ఇనీషియల్ డేస్ లో ఇట్ టేక్స్ సమ్ టైమ్. But when you do practice continuously, many formula can be in your mind 100%. How we we are writing these formula without any notes because we had a lot of practice. So instead of saying experience, we can say it's a practice. Okay, understand? Right. ఈ ఫార్ములా గుర్తుపెట్టుకోవాలి. చూడండి, స్టార్టింగ్ లో మీకు s power n ఉంది. As you move from left to right, the powers of s are in decreasing order. Here n minus 3. n minus 1, n minus 2, n minus 3, finally s power n minus 1, s power 0, and how it becomes 1. ఇక్కడ చూడండి n minus 1 ఉంది, ఇక్కడ ఏమీ లేదంటే పవర్ లో 0 రాసుకోవచ్చు. 0 అయితే డెరివేటివ్ అంటే f of 0, n minus 1 plus 0. Here it is n minus 2 plus 1. So n minus 2 plus 1, ఆ రెండు నంబర్స్ యాడ్ చేస్తే ఉండాలి. Here n minus 3 plus 2. అంటే ఎస్ పవర్ డిక్రీజ్ చేయండి, స్మాల్ ఎఫ్ కి పవర్ ఇంక్రీజ్ చేయండి. ఇక్కడ ఎస్ పవర్ 0 వస్తుంది కదా. సో ఆన్ 0 ప్లస్ n minus 1, you will get n minus 1. This is 1. సో యూనిఫామ్ సమ్ వస్తుంది n minus 1. ఇన్ దట్ వే యూ కెన్ రిమెంబర్. ఓన్లీ ఫస్ట్ ఎక్స్ప్రెషన్ లోనే మీకు క్యాపిటల్ ఎఫ్ ఉంటుంది. సెకండ్ ఎక్స్ప్రెషన్ నుంచి స్మాల్ ఎఫ్ ఆఫ్ 0, ఎఫ్ డాష్ ఆఫ్ 0, ఎఫ్ డబుల్ డాష్ 0 అండ్ సో ఆన్ n minus 1 డెరివేటివ్ 0. So n place లో 1 రాద్దాం. It means that I am talking about Laplace transform of first order derivative of f, L of f dash of t. n place లో 1 రాయండి. You will get this s into capital F of s minus small f of 0. I think this point is clear. Suppose if I write 2 in place of n, after this I will tell you its advantages. n place లో 2 రాయండి. So I will get Laplace transform of f double dash of t, second derivative. So s square into f of s minus s into f of 0 minus f dash of 0. I think these points are clear. Am I right, my dear students? Vasu, Hari Krishna, Adarsh, are you following? No issues, right? ఈ రెండు ఫార్ములాస్ లో మీకు అడ్వాంటేజ్ ఏంటో చూడండి. Here f of 0 is given. Here f of 0, f dash of 0 is given. Suppose I have a first order the differential equation is given. A first order differential equation is given. So general solution contains exactly one constant C. If you want to get the value for this constant, one boundary condition has to be given, and in this case that boundary condition is nothing but f of 0 equal to value 1, say for example. In case of second order, here f of 0 is required, f dash of 0 is required. In case of second order differential equation, the general solution contains two constants C1 and C2. So in order to get the constants for C1 and C2, two boundary conditions are required. Now using Laplace transform, if you want to solve differential equations, the two boundary conditions should be like this: f of 0 equal to value 1 and f dash of 0 equal to value 2, like this. So మీకు జనరల్ గా ఫస్ట్ ఆర్డర్ డిఫరెన్షియల్ ఈక్వేషన్ సాల్వ్ చేస్తే జనరల్ సొల్యూషన్ లో ఒక కాన్స్టెంట్ వస్తుంది. If you want to get the constant for that particular the particular constant for that general constant, see, one condition is required. That condition can be anything, f of 1 or f of 6 or f of 1 by 2. But using Laplace transforms, if you want to solve differential equations, particularly first order, the boundary condition should be in the form f of 0 equal to something. If you want to solve second order linear differential equation with the constant coefficients, using Laplace and inverse Laplace transforms, two boundary conditions are required. Those two boundary conditions should be in the form f of 0 equal to something, f dash of 0 equal to something. Very clear. This is required for me and this is required for me. Suppose when you are dealing with the third order differential equation, general solution contains three general constants C1, C2 and C3. In order to get the constants for C1, C2 and C3, three boundary conditions are required. Without using Laplace transforms, any three boundary conditions are sufficient. But in case of Laplace transforms, if you want to solve third order linear differential equation with the constant coefficients, three boundary conditions should be in the form f of 0 equal to value 1, say v1, f dash of 0 equal to value 2, say v2, f double dash of 0 equal to v3. That's the Euler restriction. So therefore, based on this formula, one can find or one can solve linear differential equations with the constant coefficients using Laplace and inverse Laplace transforms. When I go to probably I will try to start like inverse Laplace transforms tomorrow. Okay, right? That is also very interesting. So here I am going to write one important note. Using above formula, comma, Laplace and inverse Laplace transforms, comma, one can solve linear differential equations with the constant coefficients. With the constant coefficients. So when we go through inverse Laplace transforms, again I will come back to this. We will solve 2 to 3 important problems. You can easily understand. Okay, I think these points are clear, my dear students. Next, we are going to discuss very important and very simple concept, that is evaluation of definite integrals using Laplace transforms. Let's see. The concept is this: evaluation of Laplace transforms, definite integrals evaluation of definite integrals using Laplace transforms. Very, very important and very, very simple also. Let's start with some problems. Suppose I want to evaluate integral 0 to infinity e power minus 3t into t power 4 dt. I want to solve this integral. I want to evaluate this integral. Integral 0 to infinity e power minus 3t into t power 4 dt. Suppose if you do not have any formula, assume that student does not have any awareness about Laplace transforms. Then in that way, how student can proceed to solve this problem? The only thing is they must go by doing integration by parts. Assume that student does not have any awareness about gamma function, no awareness about Laplace transform. Then student we have only one alternative, that is evaluation of this integral by using integration by parts. Here power of t is 4. So you need to apply integration by parts for these 4 times, which is too complicated. So, but let us see, we can handle this in a very simple manner. This is very similar to integral 0 to infinity e power minus st into f of t dt. Am I right? So therefore, this is nothing but Laplace transform of f of t. So in this case, what is f of t? T power 4. What is s? 3. So therefore, this is Laplace transform of t power 4 when s is replaced by 3. Laplace transform of t power 4 is s power 4 factorial by s power 5, replace s by 3. So 4 factorial is 24. 3 power 5 is, this one is 27. I think this is 243. So 3 power 5. 3 square into 3. Yes. 81 3s. Yes, it is 243. So this is 24 divided by 243. Now you can see we have got the result within 30 seconds. This is the advantage of Laplace transform using definite integrals. Is this clear? Follow up, Nara, Hare Krishna, Vasu, Adarsh. Follow up, Nara. No issues, right? So this is e power integral 0 to infinity e power minus 3t into t power 4 dt. So this is exactly matching with the definition of Laplace transform. Here my f of t is t power 4 and s is 3. So therefore this becomes Laplace transform of t power 4 when s is 3. Laplace transform of t power 4 is 4 factorial by s power 5. So that is 4 factorial by 24 divided by 3 power 5. So you will get 24 divided by 243. Very clear. Very good. Very good. Let's solve second problem. Suppose I want to find out this integral 0 to infinity sin t divided by t dt. This was one of the previous year GATE question. I think it was given to civil students in 2017 for 2 marks question. Integral 0 to infinity sin t by t. Now let us compare this with definition of Laplace transform. So this is integral 0 to infinity e power minus 0t into sin t divided by t dt. So therefore this is nothing but a Laplace transform of sin t by t when s equal to 0, because s is becoming 0. So in one of the recent last classes we have seen Laplace transform of sin t by t. This is pi by 2 minus tan inverse s. Replace s by 0. Tan inverse 0 is 0. So this is nothing but pi by 2. Hope this point is clear. ఎలా క్యాలిక్యులేట్ చేయాలి? Laplace transform of sin t by t ఈ ఫార్ములా వేయండి, డివిజన్ బై t ప్రాపర్టీ. L of f of t by t. So you need to apply this formula, integral s to infinity f of s ds. In the last class, we had solved this same example. So when you apply this one, in this case, you will get pi by 2 minus tan inverse s. So replace s by 0, you will get pi by 2. Got this point? Now next, let us try to solve this problem. Integral 0 to infinity t e power minus t sin t dt. Try this. Integral 0 to infinity t times e power minus t into sin t dt. So this previous one is Laplace transform of, or I can go like this. So Laplace of t into e power minus t sin t. They asked integral 0 to infinity t e power minus t sin t dt. Right. How to evaluate this? This is resembling definition of Laplace transform. Integral 0 to infinity e power minus t into t sin t dt. So this is nothing but Laplace transform of t power 1 into sin t. Here s value is 1. Here Laplace of t sin t. This is resembling Laplace transform of t n into f of t. Laplace transform of t power n into f of t. So yesterday we solved this problem. So you will get 2s divided by s square plus 1 whole square. Of course, s should be replaced by 1. So this is 2 by 1 plus 1, 2 square, 4. So you will get 1 by 2. Hope this point is clear. Very good. The point is clear, right? Yes, let us solve this problem. Last one. Suppose I have integral 0 to infinity e power minus 4t into sin 3t dt. Let us solve this. Integral 0 to infinity e power minus 4t into sin 3 dt. Very simple. This is a Laplace transform of sin 3t. Of course, s value is 4. This is s value. So Laplace transform of sin 3t. 3 divided by s square plus 9. S should be replaced by 4. So therefore, this is 3 divided by 25. 3 divided by 25. Right, very good. Now we discuss two important results. Initial value theorem. Initial value theorem. Suppose f of t is a function. Assume that its Laplace transform exists. Assume that f of t is a function whose Laplace transform exists. In that case, what is its Laplace transform? Integral 0 to infinity e power minus st into f of t dt. So whenever there is a function f of t whose Laplace transform exists, then it means that this integral is a finite expression. It means that the function takes its values starting from 0. So Laplace transform function exists right there. Function की values second से start होते हैं. Function takes its values starting from 0. In that case, its initial value is given by f of 0 and t plus 1 with 0 రాయాలి. So therefore here I am writing this. Let f of t be a function for which Laplace transform exists. Then initial value of f of t is given by f of t equal to, you should replace t by 0, f of 0, let me write more clearly, f of 0. This I can write in terms of limits. Limit t tends to 0, small f of t, because f of 0, so it's f of limit, the initial value of f of t is given by f of 0 equal to limit t tends to 0 f of t in terms of signal variable. Limit s tends to, when t tends to 0, here t is inversely proportional to signal variable. So t is nothing but 1 by s. When t tends to 0, s tends to infinity. So limit s tends to infinity, s into capital F of s. Either by this or by this, you can get the initial value of f of t. Is my point clear? So what do you mean by initial value? And a function ki a point దగ్గర నుంచి values start అవుతున్నాయి. Here you can see lower limit is 0. It means that the function starts its values from 0 onwards. అంటే 0 initial value కాదు. 0 దగ్గర function values start అవుతాయి. అంటే f of 0. So initial value of f of t is given by f of 0 is nothing but limit t tends to 0 f of t if f of t is given. Sometimes instead of small f of t, its Laplace transform will be provided. So in that case, you should use second definition, limit s tends to infinity, s into capital F of s. I think this is clear. Next, we discuss final value theorem. These are very, very important to handle many problems. Let f of t be a function for which, here I will write short form, capital F of s exists. Capital F of s means its Laplace transform. Then the final value of small f of t is given by upper limit and then integral of infinity. So f of infinity is final value of f. This is in terms of limit t tends to infinity f of t. In terms of signal variable, as t tends to 0 infinity, s tends to 0. So limit s tends to 0, s into capital F of s. Hope this point is clear. So this is final value in terms of two limits. Previous one is initial value. Okay. So I am stopping for within 1 minute. Tomorrow I am going to discuss a convolution product. Very, very important convolution theorem, and I am going to start inverse Laplace transforms. Very, 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 very important. Never miss next to 3 days classes also. It's just a matter of 30 minutes, but you will get many points. Okay. Yeah, sir. By using Laplace transform, can we solve any definite integration problems? Chesam with the Harikrishna. Just now we had. Okay. Tomorrow we will discuss. Just now we had. Okay. Don't worry. Tomorrow you can ask me very freely. Tomorrow never miss the class. Tomorrow I am going to discuss convolution product, convolution theorem, and within 10 minutes I am going to start inverse Laplace transform. So very, very important. Next 3 days are very, very, very crucial. We are going to solve beautiful problems using inverse Laplace transforms. Okay. Right. This is Creatrix channel where you can find more than 10,000 members. This is our Telegram channel in which you can find links of our live classes every day. Every day we are sharing links of our live classes, and we are sharing notes in PDF format once class is over. These are India's #1 study channels running by Unacademy. That's why earlier I said Unacademy is the best online platform in India for all competitive examinations. Right. Thank you guys. Thank you Vasu. Thank you Adarsh. Thank you Hari Krishna. Thank you. Thanks a lot. Thanks for bearing me since last 30 minutes. Hope you had a good session. Good night. Good night all of you.